Hello everyone, and welcome to this week 1 video tutorial for PROG1198 Client Server Solutions. This week's topic is data integrity constraints. We learned a little bit about data integrity and constraints last term in your Term 1 database course, PROG1198. So some of this is going to be a review, and then some of it is going to be new or extending on the topic to learn more about it. So let's get started. When we talk about integrity, we're looking at domain integrity and referential integrity. Domain integrity is the integrity of data within a table. And we can maintain domain integrity by following some of these rules. The first being that each table must have a unique identifier. So we have either one column or a group of columns together that make up the primary key for each table. We may also have other key columns. We call them alternate primary key or unique columns, and we can use the keyword unique to denote that in our table. We want to make sure that minimum required data for a complete record is entered, so we want to try to avoid leaving null as values in various fields or columns whenever possible. And in order to enforce a rule where you can't leave a null, we use the not null constraint. And then the last one on the list here is data where applicable are within acceptable ranges. And we have two different ways we can handle that, check and rule. Now we learned a little bit about check constraints in the past, but rule is going to be new to us this time. And we're going to be looking at all of these options and more when we look at domain integrity today. The second type of integrity is referential integrity. And essentially that means that we want to maintain the integrity of our relationships between tables. So if we're making one-to-many or many-to-many or one-to-one or one-to-many recursive or any other types of relationships, we want to make sure that, that there's something there at either end of the connection. And since the database is the key storage mechanism, it should be the strictest or the most conservative point of enforcement. So when we get into the latter part of our term, we're going to learn how we can use our database as the back end for a user application. And the user application, of course, is going to have its own validation rules that it will need to follow. But we need to make absolutely sure that our database is the strictest form of validation. So even if erroneous data should make it through from the user interface and through the business layer, we want to make sure that the buck stops here, so to speak. Let's move on. We'll take a look at column level constraints. Now we've learned about column level constraints before, so this is just a bit of a review. The column level constraint is a constraint that is applied to only one field in a table, so we can write it as part of the column definition statement. In this first example where we see department code and department name, the two of those both have a constraint applied to it. Most constraints can be put with the column definition, so primary key, foreign key, unique, check, not null. All of those fields, if they only apply to one field, we can include the constraints as part of the field definition. So we're defining department code as the primary key. We're defining not null for department name. That means that you can't leave that field empty. If we want to provide a name for the constraint, then we can write it out in long form using the constraint keyword. So in this second example, we're also creating a constraint saying that this field is the primary key, but we're enabling ourselves to give it a name here. So we can compare this one to the department code one. They're both the same data type, they're both the primary key, but the one called pet ID has a name on that constraint. And you'll see later on in the course, it's really handy to have a name on your constraints, because later if you want to alter or change or remove, drop them, then you have a name to refer to. We can also create table level constraints. So table level constraints usually are written at the end after all of the field definitions, but before the end of the create statements. The order in which you write the constraints doesn't matter. You can write any of the constraints at table level. So you have an option on most constraints, whether you want to put them at column level or at table level. Don't do both because you don't need to define the constraint twice. The only time when you must use a table level constraint and you can't use a column level constraint is when the constraint references more than one field. So if you have a constraint that uses 2 or more fields in its logic, then you must put it at table level. Our next slide here is about enforcing uniqueness. To enforce uniqueness, there's 2 different ways we can do that. Either we can make a column the primary key, or we can denote it as unique. Now we know that each table can only have one primary key, and typically what we would do would be to make what we call it a programmer's key, where the data making up the primary key usually isn't part of the meaningful data about the object. Now sometimes it is, sometimes it isn't. It depends on your database design. But the primary key carries the following rules: that it can't be null and it must be unique. Because each table can only have one primary key, if you have 2 columns in which the data needs to be unique, then you can't denote both of them as the primary key. You'd have to pick one to be the primary key, and you can denote the other one as unique. So we call those alternate keys. It doesn't enforce not null. It only tests for a unique value. So it would allow one null in that column, but you wouldn't be able to have 2 or more different records having a null in that column, because then those values are no longer unique. So typically unique is paired with not null. So if we want the user to always enter a value and we can't have any duplicates in that column, but it's not the primary key, then we would create what's called a unique constraint, as we did here in this example. Now, one type of constraint that we haven't talked about yet is called a composite key. Now, a composite key is when we make the key up of more than one column or field. So what I've got in this picture here is a database diagram of a one-to-many relationship between tables pet and person. So what we've created here is a list of pets on the left side in this table, and we've got a list of persons over here on the right, and we want to keep track of which people own which pet. And it's a one-to-many relationship because each person can own multiple pets, and a pet can be owned by multiple people. Now, if you have a roommate or something and the 2 of you have a pet together, then 2 people would be the owner of the pet. So it's a many-to-many relationship. But if we take a closer look at this diagram, you can see that the key of the owners table, it shows that there's 2 keys. Person ID and pet ID are both the key. Now you know from what I just said previously that you can't have more than one primary key. So when you see something like this, it's a visual clue that the key is actually a composite. When the key is a composite, it means that it's the combination of the 2 fields that has to be unique. So there can be duplication in both fields individually, but not the combination of the 2 fields. So you can't have 2 that are the same at the same time. The most common use of composite keys is to make a primary key in a bridge table, as we've done here. And when the key is composite, you must use a table level definition. You can't define it at column level because it uses more than one column. Let's take a look at the next slide. Here's how the composite key looks in the data. So on the left, I have all of the data in the pet table, and on the right, all of the data in the person table. And the bridge table in the middle, called owners, is the table that indicates who owns which pet. So if we take a look at what data we've got here, you can see how there are some duplicates in person ID. For example, person number 2 is listed there twice. Person number 3 is also listed there twice. And there's also some duplicates in the pet ID table. For example, you see the pet DD09 is listed in 2 different places. So that pet, if we look over here, that's the pet called Spot. And Spot is owned by person number 1 and person number 9, or excuse me, person number 3. So person 1 and person 3 are both owners of Spot. And if we look up the people in the table, we can see that Marcus and Serena are sharing that dog. The key is made up of both together. So it's okay to have duplicates here as long as we don't have duplicates there. And it's okay to have duplicates over here as long as we don't have duplicates in this column as well. So it's the combination of the person ID and the pet ID together that would need to be unique. And that's how it works when you have a composite key. Here's an example of how we would make a composite key. So I've created the table called owners, and we have two foreign keys. The first is person ID, which references the person table, and the second is pet ID, which references the pet table. That makes the table relationship between owners and person and between owners and pet. Then, in order to create the composite primary key, I create the constraint at table level, and you can see how the primary key is only defined once, but in the definition we mentioned that it's made up of two fields. So the fields are comma separated inside these two round brackets. Let's move on to looking at foreign keys. The foreign key rule, often called referential integrity, ensures that when you add a record to a child table, it connects to a valid parent record. So you can't have a child table referencing something in another table unless that something actually exists in the table. So we have to determine then, how are we going to create child records and make sure that they relate to something in the parent? What happens if after creating the child record, the parent record is updated or the parent record is deleted? Now, the default action in SQL Server is that your changes are rejected. So the default action is to actually do nothing. So that means if you have a situation where you're trying to update a parent record in a one-to-many relationship, parent records can't be deleted when they're still connected to child records. And parent records can be updated, but you can't change the primary key value. Let's take a look at an example. So I've opened up my SQL Server Management Studio, and I'm going to show an example of the foreign key rule or referential integrity as applied to our company database. So our company database, you're probably familiar with it from last term. We have departments and we have employees, and there's a one-to-many relationship there such that the one department can hold many employees, but each employee can only work in one department. Now, in order to perform any actions against that particular set of tables in the database, that database in my system is called username_company. I need to make sure I'm using the correct database. So I covered this in a previous lesson, but just to refresh your memory, I want to point out you can use this drop-down to take a look at the current database that you've got selected. So right now I'm working in the master database, which is a system database that's always there for you to use, but I want to transfer over. So you can do that a couple of different ways. You can use the drop-down to select the database that you want, or you can double-click on it over here in the Object Explorer. But the correct SQL code way to do that is by using a use statement. So I'm going to put in the word use, followed by the name of the database that I want to switch to. And after that, I'm going to include Go. Now we're going to cover Go in a future class, but for now, you can just think of it as that we want to make sure that this is done executing before we move on. So it's a way to separate commands and make sure that these ones are flushed through before we move on. We'll cover that again in a future class. So once I've moved to the company database, I'm just going to write a few select statements to select all from department and select all from employee so that we can remember and refresh our memory as to what we've got going in here. So our first table is the department table, and our second table is the employee table. And we can see the foreign key field here, department code, referring to department codes in the department table. So on the topic of referential integrity, we're saying, well, what happens if we try to delete a department that is connected to one or more employees? Well, the default action here is if I delete from department, let's say, for example, we're trying to delete the accounting department. You'll see that this causes an error message because it conflicts with our foreign key reference. So this is one of the nice things about naming your foreign keys, is that you'll know exactly what's causing the problem. So I can't delete that department because it's connected to some employees. That's the default action. Now, what about updates? Let's take a closer look here at our departments. I can update some departments. I'm going to make a change to the department name. So let's change it to something different, where the department code is accounting. So I'm finding this particular record and I'm just updating the department name. And this will be allowed to pass, no problem. One row affected, that's good news. It means that our change was accepted by the system. So we can make updates to the department, but it prevents us from changing the department code because the department code is the primary key. So even though I can change the department name, say to accounting and finance, if I try to change the department code to more accurately reflect that, I want to change it to something that looks like accounting and finance, this is going to cause an error. And the reason for that is the same as the other reason. I can't change the key when it's referenced from elsewhere. So that's the default behavior. Now we have control over that. If we want to change the default behavior, we can. And the way that we can control that is when we're creating the foreign key constraint. So let's take a look at the next slide. The first one is handling updates. If we add on update cascade to our foreign key constraint definition, it means that you are now allowed to alter the primary key column value in the parent. And what will happen is, if we make changes to the primary key in the parent, all of the child records will be updated to reflect that. So if we take a look back at this, what it means is if I try to execute a command like this update, not only would it change the department code, but it would also go into the employee table and update all of those employees' department code values as well. So you think, well, that's a great idea. It's very convenient. And it is. It can be very useful and very helpful. The downside of that, though, is that if you're not expecting it, it could end up making a lot of changes in your database tables and in your data without you knowing about it. So that's just one thing to keep in mind. Now, typically, we wouldn't cascade foreign key columns where the parent column is managed via an identity. Now, in the department example, the primary key is not an identity field. It's a 4-character user-managed field. That is, the users make up what the values are going to be, like ACCT for accounting. If you have a primary key that's just an identity, then there's no reason to cascade updates because there would never need to be a reason why a field would have to change its primary key value. So if you have an identity as the primary key, then it's typically we don't bother cascading updates. But if we have the column that's managed by the user, cascading updates are a must. So it just depends on what your table design is set up as. Now we have a similar option for deletes. If we apply cascade delete on a relationship, then when you delete a parent record all of the child records are deleted too. And again, sometimes that's what you want. It can be very efficient. However, sometimes that can cause problems in your system. For example, if you delete a department and then all of those employees that work there are deleted from your system too, odds are maybe that's not what you wanted. So you have to be really careful with cascading deletes. You really want to cascade deletes only when the child record is meaningless without the parent. Now here's another option. So I think, if I'm not mistaken, I know in my sections we talked about cascading updates and deletes briefly last term, but this is something that we didn't cover. Assigning a default value. So this is something different that you can do. Instead of deleting everything or updating everything, you can take other actions on the update or delete of the parent. And one of those would be to set a default value. So it says here, if you change a primary key column value in the parent or delete the parent record, any of the child records would automatically reset to the column's default value. So let's take a look at what that would mean here. If I deleted the accounting department, all of the employees who had that dept code would have their dept code changed to some default value. Well, where do we get the default value from? It would be the same default value that was set up when we created the employee table. So we'd have to go back to our employee create statement and make sure that dept code has a default value so that we have something to reset it to if the employee's department gets deleted. Now, this doesn't work if the column doesn't have a default value assigned. So if there was no default for employee department code, then it would have no way of resetting it to anything. So you have to make sure that your table definitions for employee and department are set up to work together. And that's part of building a good, robust relationship between two entities. Now here's a third option, assigning null. If you change a primary key column value in the parent, or if you delete the parent record, any of the related child foreign keys would be set to null. Now again, this has to make sure that it works with the child table. Does the child table allow nulls in the foreign key column? If it doesn't allow that, then you're going to have some kind of collision here. So you can set null on update or delete of the parent, but that only works if the child allows nulls in that column. So again here, what would happen if we deleted the accounting department? Well, all the employees who had ACCT as their department code would become null as their department code. Are nulls allowed in the employee dept code field? Well, we'd have to go back to our create statement and review it to make sure. So let's see these little bits of code in action. If our goal is to make changes to the referential integrity relationship, the foreign key in the employee table called dept code, and the primary key also called dept code in the department table. Because the changes that we want to affect are happening in the employee table, that's the table where we need to make the changes. So that means that we're making the changes in the child table because that is where we define the foreign key constraint. So the department is left unchanged, even though what we're trying to do here is we're trying to, execute commands against the department table. Really what we're trying to say is, how is the employee table going to respond when things are changed in department? So we're making our changes to the structure of the employee foreign key constraint so that it can respond differently to actions taken on the related field in department. So in order to make these changes, I'm just going to give us a little more space here to write some more code. I need to recreate my employee table. Now I can make changes to it using an alter command, and I could just do that using alter so that we can keep the table that we have but modify the constraint. Another option is to just drop the constraint and recreate it without affecting the rest of the table. But just for full transparency here, what I'm going to do is drop the entire employee table and recreate it so that you can see what it looks like as part of a create statement. So I'm going to start by dropping the table and then writing a new create statement where we define the same employee data rather than have you watch me type it all out in this video. I'm just going to paste it in here. So here's all the same fields for employee. And now I'm going to create the foreign key constraint on department code. Now, in order to demonstrate two different types of reactions to update and delete, I'll just put it in a comment here that we're going to put in an on update clause, and then we're going to put in an on delete clause. So we're going to say that if the parent department is updated, that is, if the dept code changes, then we're going to set our employee dept code to null. So rather than just cascade the changes through, just so that we can see some of the different things that we can happen, if a department code changes, all the employees in there are just going to say that you don't work anywhere anymore. You're still in the database, you're still in the table, you're still part of the company, but your current assigned department does not exist. It is null. So we're going to put that in here. We're going to say assign null to the employee's department code if the parent department is updated. Now I'm not talking about updates to the other fields. If the department name changes or if its budget changes, nothing is going to be affected in the employee table. It's only if we change the department's code. Then the employee's dept code has to change to reflect that. And it's going to change to null. Now what about if the parent department is deleted? Now typically we don't want to just randomly delete things in our database without having some kind of information, at the very least, warning somebody that that's going to happen. But just for demonstration purposes, we're going to say if the parent department is deleted, then we're going to delete all the employees too. So there's two different actions that are going to happen, one on update and one on delete. So I'm going to come down here and I'm going to create my foreign key constraint, and I'm going to start out the same way that we always do, with the keyword constraint, and we're going to give the constraint a name that reflects what its purpose is. In this case, a foreign key between parent table department and child table employee. We're going to reference that it's a foreign key, and we put in the name of the field. Now the name of the field refers to the name of the field in this table. So just for future reference, if the two fields ever have different names, then you want to make sure that you do them in the right order. The one defined as the foreign key is the one in the child table. Then we're going to say that it references the parent table department dept code. So again, if that had a different name in the department table, this is the one from the parent. And typically we would just stop here. But because we want to assign these extra actions, I'm going to put in on update. And I said that we're going to assign null if the parent's dept code is updated. So we're going to write on update set null. I'm just going to move this down to the next line. They don't have to be on the next line. I'm just trying to keep it from going off the side of the screen. So there's our set null for update. Now what about on delete? I'm going to write the next line on delete cascade. So cascade means perform the same action on the child that was performed on the parent. If the parent is deleted and we want the child to be deleted too, then we put on delete cascade. And we can put them on their own line, or we can put them all together on the same line. White space doesn't matter programmatically in SQL, so it doesn't matter where you choose to put them, but you want to be consistent and make it readable so that humans have an easy time deciphering your script. Okay, so I'm going to execute these 2 lines of code to drop and then recreate our employee table. So that deleted it. Now we remake it, but of course now it is empty. As it's a newly created table, there's not going to be any fields or any values rather in it. I can take a quick peek inside just to prove that. You'll see that all the employees are gone. So in order to fix this up, I'm just going to run our same insert statements that we had so that we get the same data back. Our typical insert statements. Hopefully you guys remember this example from last term. So I'm going to execute the insert statements, and then we'll take a look to make sure that we've got our employees back. Okay, so all of our employees, nothing changed in the data, nothing changed in the fields. The only thing that changed is that referential integrity, the relationship between department and employee. What happens to employees when departments are updated or when they're deleted? One thing I want to point out, an extremely common error is you really want to put a comma in between these. I've seen that a lot of times where, you think, oh, I've got 2 different things that I want to happen. I'm going to comma separate them. That's not the case here. They just come one right after the other. And it doesn't matter which order you put them in. Okay, so now that our employee has been recreated, I'm going to test out the new actions. So I'm just going to minimize this for now. And we'll go up here. I'm going to minimize the create statement as well, because I want to test these same 2 actions again. Now we saw before that I couldn't delete and I couldn't update the department code. Both of these were just rejected with an error message. But now that I've made that change to the structure of the employee table, I'm just going to paste these down here. What's going to happen if I run the delete query and I delete the accounting department? Remember, before it was rejected, but now it was successful. So let's take a look at what we've got in the department table and the employee table after executing my delete statement. So we can see in our result set that the accounting department has been deleted, but also look at our employee list. We only have 5 employees. We had 8 before. So 3 of the employees got deleted as well. And if we just quickly take a look at the insert statements, you'll see that 3 of those employees, the ones that got deleted, were the ones that were in that accounting department. So that's how the cascade works. When you delete the parent record, all the child records are deleted as well. Now we'll just demonstrate the last one here, the update set null. Now I can't run an update on the accounting department anymore because I just deleted it. So I'm just going to modify this so that it performs an update on the information systems department instead. So I'm going to look for the information systems department, and I'm going to change its department code to ITEC. Maybe the department is going to get renamed to Information Technology. Actually, let's add that in. Then it can be a little bit more of a real-world type of example. So we're renaming the department to Information Technology, and that's changing its department code as well. So when I run this update, you'll see again I get success. So it's no longer rejected because of the foreign key constraint. And we'll see how the changes are reflected not only in department but in employee as well. So here's our new department record with a new code and a new name. And you'll see down here, all of the employees that used to work in Information Systems, ISYS, are now working in a null department. So rather than automatically moving them to the new department, we get a bunch of people who are not assigned to any department. The reason why that happened was because of our create statement saying on update set null. So the department codes were updated in the parent table, and that means set all the related child record foreign key values to null. Now, on the topic of nulls or not nulls, we use not null on fields that are mandatory for a complete or comprehensive records. Not null is always applied at the column level. And typically, we do assign foreign key columns to not null. That is the most common thing that we do when we create a one-to-many relationship. Usually, we would want to say there has to be one matching foreign key. For every employee, they have to be assigned to some department. Now, if that's not the case in this company, if employees can be hired without being assigned to a department, then you might want to make that foreign key field department code allow a null. So that is part of the design phase of your database, determining which fields are required and which are optional. Now here are some examples of default constraints. Default works to support complete records and to simplify inserts. If you don't provide a value for that field in an insert statement, then the default value will be used instead. If you want to purposely leave that field null, then you have to explicitly provide the null value. You can't just leave it out. If you leave it out, it uses the default. Defaults have no action in update statements. However, if you have on update cascade like we looked at before, I'm just going back. If we have on update set default, then it's really important to make sure that you have defaults set in the child. And this is the only time that updates or deletes would use a default. So here are 3 different ways that we can define a default constraint. There are others, but these are the 3 most common types. So the first one is by providing a literal value. So at column level, we define the default with a value, and then you have to make sure that the value you provide matches up with the data type. The second one is you can create a default value that comes from a function call. So in this case, we have a default of calling the getDate function, which obtains the current date and time. And that value is used as the default. So if we don't specify a value for cust order date, then it defaults to this exact moment right now. Now the third option here is another example that uses a literal. In this case, it's a varchar literal, so just text. But I've added on that extra bit of syntax to create a named constraint so that we can give the constraint a name. And remember what I said earlier about naming constraints. It's better to give your constraints a name because then later, if you want to change them or if you want to drop them, then you have a way of accessing it easily. So if we determine that we don't want the default to be Welland anymore, we might want to change it to Toronto or Niagara Falls or anything else. It will be easy to alter that constraint because you can call it by its name. Next, we're looking at check constraints. So check constraints are used to validate data that is coming in. Check can be defined at column level if the logic only applies to that column. If the logic applies to 2 or more columns, then you have to put check at table level. So we have two check constraints in this example, one here and one down there. So the one at table level is applied only to the res date field, and the check constraint has the following syntax. We use the word check followed by a set of round brackets, and inside the round brackets is a Boolean expression that evaluates to true or false. If the expression evaluates to true, then the value is allowed, and if it evaluates to false, then the value is rejected, and your query will throw an error message. So our first check constraint for res date says that the reservation date has to be greater than or equal to get date. So get date means today. The reservation has to be today or later. The check constraint at the bottom here is posted at table level because it involves two different fields. So in this case, we're comparing one field's value against another field value, that the start time has to be less than the end time. And we have these two fields defined here. So when we go to insert a record into reservation, it validates that the value we're using for res date is today or in the future. And it also validates that the value you provide for start time is less than or before the value that you provide for end time. So we use two check constraints as validation so that we can make sure our data in our table makes sense. So that finishes up our slides about data integrity constraints. You may notice that I mentioned there are two types of constraints, check and rule. We're going to look at rule in a future class when we apply it to different kinds of fields. Namely, we're going to look at user-defined data types and other types of fields that are created on the fly, like calculated columns. And we mostly use rule to apply those. So I'm going to leave rule for later for now. So if you have any questions about any of these topics, I do suggest that you drop into our Blackboard meeting time in Blackboard Collaborate. It's scheduled during our regular class time, so you should be able to drop in on me there. Alternatively, you can send me an email and we can converse that way, or we can set up a meeting over in Microsoft Teams as well. Now, your goal for this week is to complete the exercise posted in the Week 1 folder on Blackboard. As shown on the screen here, you can see at the bottom of all of our slides, I posted exercise 1, which has two parts to it. We have an SQL review, and we have a little exercise about data integrity constraints as well. So the instructions are there, as well as the work file. I do suggest that you work your way through that exercise just to make sure that you are getting back in the swing of things and that you're familiar with all of these concepts. So I hope you all have a great week, and I will see you in the next one.